Hello, my name is Wenjun, and I will be discussing about the applications of calculus. My presentation includes four parts. First, introduction to economic applications of calculus, and the second part, applications of derivatives in economics, and the third part, the watch method, and last, the moment and the central mass. Part 1, introduction to economic applications of calculus. Role of calculus in economic optimization. First, maximizing profit and minimizing cost. Calculus is instrumental in finding the optimal production levels that maximize profit or minimize cost. A key objective for businesses. By setting derivatives to zero, economists and business analysts can identify critical points where maximum efficiency or profit is achieved. And about the dynamic adjustments in economic models. Economic models often require dynamic adjustments based on real-time data, and the calculus provides the tools to adjust these models accordingly. The ability to differentiate and integrate economic functions allows for the modeling of complex economic scenarios and the prediction of outcomes under different conditions. Part 2, part 1 is short. Applications of derivatives in economics. First is the cost functions. The definition: the cost function represents the total cost incurred by a business to produce a certain quantity of goods or services. It includes both fixed costs and variable costs. Its mathematical form is CX equals CF plus CVX. CX is the total cost as a function of quantity X. CF is the fixed cost, and CVX is the variable cost. So, cost functions can help with identifying minimum cost points. With derivatives, business can pinpoint the production levels where marginal cost equals marginal revenue. A key strategy for cost minimization. This approach helps in understanding the cost structure and optimizing resource allocation to achieve the lowest possible production cost. And it can also help with the elasticity and price derivatives of demand functions, provide insights into price elasticity, allowing businesses to adjust prices to maximize revenue. By understanding how price changes affect demand, companies can set prices that balance volume and price to achieve optimal revenue. And about the average cost functions. The average cost function represents the total cost per unit of output given by the equation. The derivative of the average cost function helps identify the change in cost per unit as the output increases or decreases. Take an example: if the total cost function is x equals 500 plus 20 times x, the average cost function cx over x. And taking the derivative of the average cost function gives the rate of the change of the average cost with respect to output. And this shows that as x increases, the average cost decreases. But the rounded functions, it represents the total income generated by a business from selling a certain quantity of goods or services at a given price. Its mathematical form is x equals p times x. X is the total revenue as a function of quantity x, and p is the price per unit of the good or service. X, quantity of the goods or services sold. Rounded function can help with the optimal pricing strategies. Revenue maximization is achieved by analyzing the first derivative of the revenue function, which indicates the rate of change of revenue with respect to the quantity. Businesses can use the information to set prices at maximum revenue, taking into account the price elasticity of demand. Impact of price changes on revenue. The second derivative of the revenue function can indicate the concavity. Help businesses understand the diminishing returns of price increases. This analysis is crucial for setting promotional prices or adjusting pricing strategies in response to market changes. About the average revenue functions, the derivative of the average revenue function with respect to x gives that to the rate at which average revenue is changing as output increases. I'll take an example using the same revenue function in this equation. And taking the derivative gives the rate of the change of the average revenue dr over dx equals -2. This shows that as x increases, average revenue decreases. And the profit functions. The profit function is represents the total profit earned by business, which is the difference between total revenue and total cost. This mathematical form is tax equals x minus cx. Px is the total profit as a function of the quantity of x. Profit functions can help with the maximizing profit. Profit functions are crucial in business decision making, and their derivatives help identify the operation level that yield the highest profits. By setting the first derivative of the profit function to 0, businesses can find the optimal quantity to produce for maximum profit. The second derivative test can help determine whether a critical point is the maximum or minimum, which is essential for minimizing losses in business operation. This analysis is particularly useful in volatile markets where the risk of the losses is high. The businesses need to make quick adjustments, to minimize the risks. And about the average profit functions, the derivative of the average with respect to x tells how the average profit changes as the output increases. For example, using the profit function, the average profit function is EPX is the equation over x. Taking the derivative of the average profit function gives the rate of change of average profit. And about the Washing method, let's first understand what washing method. The washing method is the calculus technique used to calculate the volume of the sleeves of rotation by considering the area of washers formed by the rotation. This method is particularly useful for sleeves that have a hole through their center, such as the torus and or cylindrical shape. Engineering the washing method is allowed to calculate the volumes of the materials needed for the manufacturing, such as the pipes or cylindrical structures. And this method simplifies the calculation of volumes for cylindrical objects, which are common in construction and mechanical engineering. It's a mathematical calculation. The general form for the rotation by the x-axis. V equals pi times integration from a to b form x squared minus the inner radius s squared dx. And about the y-axis is this. The most important, let's look at the volume and the calculation steps. First, determine the x of rotation, and find out the region is rotated about the x-axis, y-axis, or another x. And number 2, find the radius. Determine the expression of the out radius and the inner radius as a function of x or y, depending on the x. The 3 set the limits of integration. Define the interval a to b or c to b based on the region's boundaries. And the last step is integrate. Plug the radius and the limits to the motion method of volume and solve for the volume. Let's have a practical example. Let's consider the region bounded by the curve y equals square root of x and the x-axis rotated around the x from x equals 0 to x equals 4. Let's first determine the axis of rotation as about the x-axis and find the radius, the radius And the outer radius and the inner radius. The outer radius x equals the square root of x, the curve rotated around the x. The inner radius, there is the hole in the middle of the solid. The volume of the solid, if we take this data to the forum and calculate, the limits of the integration is x equals 0 to x equals 4, and then we calculate the equals 8 pi. So the volume of the solid is 8 pi cubic unit. And the last part, moment and central mass. Moments is a matter of turning, in fact, forcible point in physics. Moments are used to analyze stability and balance of objects. Moment of force is given by the product of the force in the perpendicular distance from the point to the line of action for the force. In the central mass point of view, the entire mass of an object can be considered to be constrained for the purpose of analysis. It is the point where some of the moments of mass elements about the x is 0, providing a reference point for the object's balance and stability. According to our textbook, I found this quote. Take example, consider the region bounded by the curve y equals the square of x and the x from x equals 0 to x equals 1. We want to find the central rate of this region. First, we compute the area of the region. The area of the region, we just integration this the fx dx equals the area is 1/3. Now we compute the first moment about the max. We calculate this. We take this data to the volume. Actually, it's and the last step is x coordinate of the central rate. X bar is equals mx over e. So central rate of the rating is this. What about the engineering application? Engineering, the central mass is crucial for ensuring stability of structures such as bridges and buildings and their various loads. By calculating the central mass, engineers can design structures that are less prone to tipping or collapse, ensuring safety and durability. About dynamic balance in vehicles, the central mass affects the dynamic balance of vehicles, influencing their handling and stability during trains and maneuvers. In the automotive industry, central mass is carefully considered in design of vehicles to ensure optimal performance and safety. A real example, a central mass in sports equipment. In sports, a central mass of equipment like golf clubs or tennis rackets is designed to optimize performance and control. Understanding the central mass helps athletes adjust their technique to improve the balance and precision in their movements. The fitness by the central mass plays a role in balance and stability, which is crucial for activities like walking, running, and jumping. Training and exercise can help improve the body's central mass distribution, enhancing athletic performance and reducing the risk of injury. That's all. Thank you.